Click on the calculus button. Let's go down to differentiation and find the derivative by the definition. And okay, I believe we're in this section here. 3-1. That's going to be it. I was hoping some smaller numbers would come up, but that'll work. So we have g of t is equal to 23t plus 6. G of t, let's all write that down. 23t plus 6. Alright. We got it written down, and look, magically appeared on the board there. So we've already got the definition of the derivative written up. So this is our definition. Now, let's go ahead and write our g of t, which is equal to 23t plus 6. And we want to find g prime of t. Now let's take notice here. We're using f, it's the name of our function, and we're using x. Okay, so just pretend this is a t right here. This x is a t, right? And of course that's a g. First thing we want to find is going to be g of t plus delta t. Alright, that's going to be this guy right here. So that'll be the first thing we're going to find. So we're going to take the t plus delta t, and we're going to substitute it in right there for that t. So we got t plus delta t. And then, of course, we have plus 6 right here. Alright, and let's go ahead and just distribute that 23 across. We might as well just get that out of the way. So we have 23t plus 23 delta t, and then plus 6. Plus 6. Now we're going to plug all that in to this up here. So we end up with f prime. Whoa, I just about made a mistake there. Let's not do that. We're going to end up with g prime, right? Because that's what we're trying to find. G prime of t is equal to the limit as delta t approaches 0, and then we're looking at this one here, and we already did that. That's right here. So just write all that in. We have 23t plus 23 delta t plus 6 minus, right? Minus, of course, this is not f of x here. This is g of t, right? Minus the function. And if you don't mind, I'm going to distribute that negative across. So we have 23t minus, I'm distributing the negative across, so we're kind of skipping that step, right? Distribute the negative across there, right? This minus sign. And that's all over. That will be all over delta t. Okay? So now what can we do? Well, we can now cancel out some things, and that's what's going to always happen. We're going to always end up canceling out the function. We're going to find it in here and cancel it out. Alright, so let's do that. So we've got a minus 23, we got a positive 23. So you see those guys cancel out. We got a plus 6 and a minus 6, and they're going to cancel out also. And now what we're going to do is end up going back and rewriting this. And we'll go ahead and rewrite g prime of t is equal to the limit as delta t approaches 0. And so what are we left with? We're left with 23 delta t. And that's what we're left with on top, it looks to me like, over delta t. Now as you can see, the delta t's can cancel out. We got a delta t up here in the numerator and a delta t down here in the denominator, and those can cancel out also. And let's just go ahead and rewrite this right here. So we have g prime of t is equal to the limit of delta t approaching 0, we should always rewrite this, of 23. Now, the limit of a constant is just the constant, right? So what is g prime of t equal to? G prime of t is equal to 23. Now, when you do this a few times, you're going to notice that every time we take the derivative of this thing, it's going to always be that number. That derivative will always be the 23. Alright, you should graph this out and see the reason why. Why is that? Okay, so moving over here, and of course, and I hope I use t's and delta t's in this definition, and I do. Okay, so as you can see, we just go through all the processes we already went through, and there we go. Alright, so practice that. You'll get it down easily. Let's go back to home, and I'll see you there. Bye.